So there are lots of exponential and logarithmic functions. The general exponential form looks like, say, f of x equal to b to the x. The general logarithmic form looks like g of x, to use a different letter, equal to log base b of x. The restrictions on b are the same for both of these. We have to have that b is positive and b is not equal to 1. Not equal to 1 because, well, 1 to the x is kind of just boring, right? If you have 1 to the x, it's always just 1, and it's not really an exponential function, it's a constant function. Over here, 1 is actually quite problematic, because if you have log base 1 of x, the only way that works is if x is equal to 1. In fact, here, f of x equal to b to the x is a horizontal, 1 to the x is a horizontal line, and log base 1 of x would be a vertical line, x equal to 1, which is weird. We need to be positive because, well, you can't take the log of a negative number. Not so the base is positive, not x. X has to be positive, but the base has to be positive because negative bases, well, you could have, like, say, a negative base to the 1/2 power, but that's the square root of -4, which is imaginary, and we don't want imaginary outputs, we want real outputs. So we need this to be true. Here's our general shape for these functions. Here is, so the one I usually really think of, the base I like the best, base, I can spell base, is e, which is approximately 2.7. So I'm really thinking of this as f of x equal to e to the x, and this other function down here as g of x equal to the log base e of x, which you're certainly allowed to write the log base e of x, but the more standard abbreviation is g of x equal to the natural log of x. They mean the same thing, we're just lazy and we like to write less letters. And notably, these functions are inverses of each other. That's the point 0, 1, that's the point 1, 0, and these functions are reflections of each other, if I've drawn it well, across the line y equals x. In fact, really the way we find the logarithmic functions is by taking the exponential function and saying we'd like to have an inverse, right? If you take the exponential function y equal to e to the x, if you switch x and y, and then try and solve for y, well, you can't solve for y without a logarithm, so you take the natural log of both sides, but then the y can come down, and the natural log of e, or the log base e of e, that's just equal to 1. So the inverse function is y equal to the natural log of x. So these are inverses, meaning they undo each other. Meaning when you compose them, let's say you take the natural log of e to the x, you get x. Or the other way, if you do e to the natural log of x, you get x. Those are good things to know. So that's what the graphs look like. And a couple of things that might be somewhat notable. This erased ahead of time, slacking. A couple things that might be notable are that, where'd you go here? No, I guess not. Oh yeah, so that all the x and y things are interchanged. The domain of e to the x, or f of x equal to e to the x, I should really write, is everything. So is the range. Of g of x equal to the natural log of x. And that's something that's generally true. If functions are inverses of each other, then their domain and range are switched because x and y are switched. Similarly, the range of f of x equal to e to the x is the positive numbers, right? If you look back at the graph for a second, oh yeah, look, this is always bigger than 0. So is the range, sorry, not the range, the domain of g of x equal to the natural log of x. Also 0 to infinity, all the positive numbers. A couple other things. F of x equal to e to the x has a horizontal asymptote at y equal to 0. G of x equal to the natural log of x has a vertical asymptote at x equal to 0. Look, I just switched y with x and I got x equal to 0. F of x equal to e to the x has a intercept at 0, 1, because e to the 0 is equal to 1. G of x equal to the natural log of x has an intercept at 1, 0. Switch x and y. Something I've told my students in the past, if you look at your right hand, and hopefully this looks right when you're watching this, should, right hand, this line up here kind of looks like e to the x. This line over here kind of looks like the natural log of x. My hand is not great for it because there's lots of other lines, but you younger people might have less lines on your hands and be able to see, oh yeah, that and that. So make sure you look at your right hand though, not your left hand. All right, I think that's good. I'm going to stop there.